Hello, I'm Yuzuru Kitamura from Tokyo University of Agriculture and Technology. Now, I start my presentation about the strategy of my agent, CostAverse Agent. Here's the contents of my presentation. I'm going to talk about my agent concept, proposal strategy, acceptance strategy. To begin, I will explain my agent concept. My agent is based on the Better Think agent published on the tutorial Developing an Agent for SCML 2025. Because of narrow price range in this year's rule, my agent will ignore price and focus only on quantity. This agent is averse to pay cost. Cost means disposal cost and shortfall penalty. In this game, each time a simulation is run, the multipliers for the shortfall penalty and disposal cost for each agent change according to the given probability distribution. My agent's primary strategy is to avoid whichever is greater between the shortfall penalty and the disposal cost. I will now explain the proposal strategy. Originally, Biddering agent distributes needs almost randomly. Strictly speaking, the distribution is not entirely random, because at least one unit is assigned to the negotiating partner. This figure is one example. If there are six amounts of exogenous contract, Biddering agent will distribute 3, 1, and 2 respectively. In other cases, this might distribute 4, 1, and 1. This agent offers equal quantities to all my negotiators. This example, it distributes 2, 2, and 2. When unequal, it distributes 1 to the others and then distributes all the remainder to a random partner. We will now look at acceptance and response strategy. Bidding agent selects the element whose sum of the offered quantities are closest to the needs in percent of offers. In this example, the quantities 2, 1, and 6 are offered. The element in parcel of the total 6 is closest to the needs of 5, so it is selected. On the other hand, Cost Averse Agent selects the element whose total offered quantity does not exceed the SDR threshold and is closest to it. When SDR threshold equals 0, elements greater than 5 is not selected, and the closest set of 2 and 1 among the others is selected. I will explain the SDR threshold later. For those who rejected offers, my agent makes counterproposal equal to the shortfall. In this example, 2 units are missing, so 2 units are ordered. This counterproposal is repeated until some of the offered quantity match to the needs. Let me now introduce a metric that I have defined, which I call the SDR, or shortfall to disposal ratio. SDR equals the shortfall penalty over the disposal cost. The interruption is as follows. A large SDR means shortfall are costly. If the SDR is about 1, the two costs are balanced. And if the SDR is small, disposal becomes costly. In terms of decision making, a large SDR implies that the acceptance threshold should be strict since the risk of a shortfall is severe. A small SDR implies that the acceptance threshold may be looser, as the system can be tolerate more excess orders. In short, the SDR is a self-defined metric that adjusts the order acceptance threshold according to the relative risks of shortfall versus disposal. Next, I introduce the SDR threshold. Here is my definition of the SDR threshold. As the negotiation rounds progress, the threshold for accepting excess quantity is increased. Generally, negotiation rounds tend to end in 5 rounds or less, so this function is linear rather than curved. For example, when the SDR threshold takes the value of 1, this means that the agent is allowed to accept an offer that is 1 unit higher than its original needs. In this case, the cost averse agent would choose an offer of 6 units.